What's up guys, welcome back to the channel. Today on this video we'll be doing this question paper that you see here. Now this question paper is a national certificate for mathematics and 4, which was written on the 30th of July 2025. So on this video we're gonna focus only on question 4. Just in case you haven't watched question 1, 2 and 3, I'll leave a link on the description, and also the icon will pop up there on top right where it contains those 3 questions. Now on our right here we have the QR code where you can scan to join our WhatsApp group. That's where we share lots of information concerning mathematics, and also when we do live streams I share the links there. All right people, so before we start with this question, I will make sure that I leave the timestamps for each and every question, just in case you don't want to watch this question 4 in a sequence order. So without wasting any time, let's go to question 4. All right guys, here is our question 4. Now question 4, it is based on differentiation guys, or derivatives. So it also consists of 4 questions. So we're going to start with 4.1, which is this one here. We're going to copy it, paste it where it's space, and then we solve it. All right guys, let's look at 4.1. Now the question goes like this: given is f of x, which is equaling to 4 multiplied by x cubed minus 16x. Then they say here, calculate using differentiation the coordinates of the turning point as well as the point of inflation. So what they want here, they want us to find the coordinates of the turning point and then the point of inflation, and then we must use differentiation to do such. So here is the function that they gave us to work on. Now the first thing that you must do here guys, in order for you to find the turning point of this graph or this function, you need to derive this function that is given to us once. So dy over dx is going to be 0, right? So we're going to derive this function that is given to us. So we can say 4 multiplied by 3, that is going to give us 12, and x squared, right, minus 16. But let us not forget the derivative is equaling to 0. So from here we can solve for x. We have to transpose the 16 to the other side. Now this is going to become positive 16. So we're going to have 12x squared is equaling to 16. And then from there we divide by 12 throughout. Let's divide by 12 guys. When you divide by 12, so we're going to have x squared is equaling to 4 over 3. There we go. Because you're looking for x, we're not looking for x squared. We have to square root both sides. So let's square root both sides. Right. So we're going to write the final answer on top here. X is going to be equaling to plus or minus. Remember, once you square root, the answer is going to be plus or minus. So it's going to be plus or minus 2 over root 3. There we go. So meaning x is plus or minus 2 over root 3. Right. So we need to find the y values of these turning points. So you can write here when x is equaling to positive 2 over root 3. What is our y? Right. So basically what we're going to do here guys, we're going to substitute this x to the original formula there. So let's do it. So y is going to be equaling to, wherever there is x guys, we're going to substitute with the x that we have here, which is 2 over root 3 to the power of 3. There we go. Minus 16, and then we have 2 over root 3. There we go. And then here our final answer is going to give us negative 1, 2, comma 3, 2. Let me just create a little bit of space here. So we can say turning point 1. Let's call this one turning point 1. When x is positive 2 over root 3, our y is negative 12, comma 3, 2. There we go. So this is our turning point 1, the coordinate of the first turning point. Now turning point number 2, we can say when x is equaling to negative 2 over root 3, what is our y there guys? Right, what is our y? So again, we're gonna do what we did here. We're gonna take the x value and substitute with negative 2 over root 3 from the original equation. So y is going to be equaling to 4. Then wherever there is x, we substitute with negative 2 over root 3 to the power of 3 minus 16. And then we have negative 2 over root 3. And then we put this on our calculator. This here is going to give us positive 12.32. So we can say turning point number 2, when x is negative 2 over root 3, our y is going to be positive 12.32. There we go. So we have these two turning points here, guys, meaning the first question where they want us to calculate the coordinates of the turning point, we managed to get it. Now the second part of this question is to calculate the point of inflation. Now I'm gonna continue here, guys, and let me just rewrite the question. So the question, it goes like this. We can say y is equaling to 4x cubed minus 16x. What we have here, guys, is that when you calculate the point of inflation, you have to derive this equation 2 times, and it should be equaling to 0. So we know that the first derivative, dy over dx, it was 12x squared minus 16, right? And the second derivative is gonna be as follow. We're gonna have 24x is equaling to 0. All right, guys, remember this second derivative, when we are looking for point of inflation, it's supposed to be equaling to 0. So if we are solving for x, guys, we will divide by 24 throughout, 24 throughout, meaning our x here is going to be 0. Now it's time for us to find the y coordinate of the point of inflation. So when x is equaling to 0, what is y? That's the question that we have. So we're going to substitute the x value to the original. Always, guys, whenever you're looking for the y coordinate, make sure that you substitute the x value to the original equation. Okay, y is equaling to 4. Then wherever there is x, we put 0 because that's our x to the power of 3 minus 16 multiplied by 0. So y is also going to be 0. So point of inflation, it's actually 0, 0. So that is your final answer, guys. I hope you managed to get this one. Really, it was not that difficult, guys. It needed you to understand how to calculate the turning point and the point of inflation, and how to derive as well. Because in order for you to calculate the turning point, you needed to derive once and equate it to 0. And then when you calculate the point of inflation, you needed to derive twice and equate it to 0. So the question here, guys, they never specified whether to distinguish which of these two turning points supposed to be maximum or minimum. So if they don't ask you this, guys, it's best not to do it. Remember, time is not on our side. But if you have enough time, you can do it, guys. You can do it to distinguish between the two, which one is maximum, which one is minimum. So guys, I hope you managed to understand this. If it so happened that you didn't understand, do not forget to watch the video at the point where you got lost. And if that doesn't help, you can comment on the comment section. But at the same time, guys, if this video helped you to understand, do not forget to like, subscribe, share the video, and also comment if you have any comment on this video. All right, guys, we are done with 4.1. How about we do 4.2? All right, guys, let's look at 4.2. Here is our 4.2 here. I'm gonna copy this question as well, paste it where there is space, and then we solve it. All right, guys, here is our 4.2. Now the question is very simple here, guys. It goes like this: expand, open bracket, 2x plus 4 close bracket to the power of half to 4 terms only. So what is needed for us to do here is to expand this expression here to 4 terms. Now, in order for us to expand this expression, we need to use the binomial theorem. All right, people. So the formula for binomial theorem, let me show you very quickly. We have x plus h to the power of n. When we expand it, the first term is going to be x to the power of n. The second term is going to be n multiplied by x to the power of n minus 1 multiplied by h. And then the third term is going to be n multiplied by n minus 1 divided by 2 factorial. Then we have x to the power of n minus 2 h to the power of 2. And then the fourth term, which is the last one, guys, is going to be n multiplied by n minus 1 multiplied by n minus 2 divided by 3 factorial. And then we have x to the power of n minus 3 and h to the power of 3. So these are the terms that we should stop at. Right, so you must able to know this formula, guys, because this formula, it is not given to you on the formula sheet. If you don't know this formula, chances are you will struggle to find the answer here. But before we solve this, I've made a video explaining how this formula came about and how to memorize it. I'll leave that video on the description, and also that video will pop up on the top right of the video that you're watching at the current moment. Now let's rewrite our expression then. So we know that we have 2x plus 4 to the power of half, right? In this case, let me just name them on top here, because this can be confusing. Our x here, it's actually 2x, right? And then our h, it's actually 4. And then our n is actually 1 over 2. So when we substitute here, we should consider that most people, they tend to forget that coefficient of x when we substitute. So let's start. The first term here, as you can see, is x to the power of n. But what is our x? Our x here is 2x, right? And what is our n? Our n is half. There we go. And then we say plus. And then the second term, we have n, which is 1 over 2, right? Multiplied by x. What is our x? Remember, is 2x to the power of n minus 1, which is half minus 1, right? Multiplied by h. Our h, which is 4. There we go. Now let's go to the third term. Now let's continue plus, right? Now the third term, as you can see, we have n, right, which is 1 over 2, right, multiplied by n minus 1, which is 1 over 2 minus 1, right? All this is divided by 2 factorial. There we go. And then we multiply by x, but our x, what is it? Is 2x to the power of half minus 2. And then our h there, which is going to be 4 to the power of 2. Remember, h to the power of 2. And then we do the last term, guys. So our last term, we have n, which is also 1 over 2 multiplied by n minus 1, 1 over 2 minus 1. There we go. Half minus 2. And then all this is divided by 3 factorial. There we go. And then we have x, which is 2x to the power of half minus 3. Right, we need to create more space. Let me just zoom down a bit, guys, so that you can see. And then multiply by h to the power of 3. So our h is 4 there, so it's going to be 4 to the power of 3. Guys, I hope you can see. Since I've zoomed down here, guys, I hope you can see. All right, so let's continue here. Now let's start with the first term. Our first term, we have 2x to the power of half. You can just leave it like this for now. And then our second term, what you have to do here, guys, you take your calculator, we insert half, and also you insert this 4 there. And then when you do that, you will have the following: plus 2. And then what we have there, we have the following: we have 2x to the power of half minus 1. So this 2x is still having the power of half minus 1. What is half minus 1? This is going to give us negative half. There we go, as our exponent. Remember, this negative half is only affecting the 2x there. And then we go to the next one. Now the next term, which is the third term, all this here, you put it inside the calculator, guys, including 4 to the power of 2, right? Now if you do that, what you're going to have here, we're gonna have negative 2. We're still gonna have 2x, so we have half minus 2 as an exponent. This is gonna give us negative 3 over 2. There we go. And then we do the last term there. So the last term, we're also going to take all of this, guys, all of this, put it in a calculator, and we multiply with 4 to the power of 3 there, right? So if we do that, we're still going to have the following: plus 4, and then we still have this 2x. So 2x to the power of half minus 3, that is going to give us negative 5 over 2. There we go, guys. But we are not done. We need to simplify these ones further. So if we simplify them further, the first one, guys, we're still gonna write it like this, still fine. 2x to the power of half. There we go. The second one, we can change the exponents to be positive. We still have that 2 there on the numerator, and then the base here should go to the denominator, which is gonna be 2x to the power of half, because our half is going to be positive now. And then we look at the third term, we have negative 2 as well. But then let's look at our exponent. Our exponent is negative 3 over 2. So we take the base there, which is 2x to the power of positive 3 over 2. There we go. And the last one, we're going to have 4, which is the numerator. And then let's look at the base there. The base is 2x, but our exponent is negative. So this is supposed to go to the denominator. So it's going to be 2x to the power of 5 over 2. Right. Now you can write this answer in terms of SADs. SADs meaning in terms of roots. So let me create a little bit of space again, guys, so that you can able to see what I'm talking about here. I'm going to try with the bigger font here. So the first term, you can write it as root 2x, right? Remember, this half here as an exponent is affecting 2 and x as well, right? And then we say plus, right? We have 2 there on the numerator. And then what we're going to have here, we're going to divide by root 2x. There we go. And then we say minus. On the numerator, we still have 2. And then on the denominator, we have root, right, 2x to the power of 3, right? And then we say plus, right? We have 4 there. And then on the denominator, we're going to have root of 2x to the power of 5. There we go. Right. We can even go further, guys, but this is the answer. We could go further because the last two terms there, the denominators, we have the power of 3 and 5. So we can simplify them. Let's look at the first term. We have 2x there, root 2x plus 2 divided by root 2x minus 2 divided by root. Now, if we remove the brackets there, 2 to the power of 3, this is going to give us 8, and then that is going to be x to the power of 3 plus 4. Then we divide them, and then we say root, and then we know that 2 to the power of 5, that is going to give us 32, and then we have x to the power of 5. So there, guys, that is our final answer. I hope you guys managed to understand this one. It was a bit confusing, especially if you do not know how to use a calculator at the point where you substitute your values using the binomial theorem. Hopefully you managed to use your calculator correctly, guys. Right? Again, my good people, if you didn't understand, go to the point where you didn't understand, rewatch this question, and also if that doesn't help you, leave a comment in the comment section. I'll try to help you to my level best. But if this video helped you to understand, my good people, do not forget to like, share, comment, subscribe to the channel as well. You can always support our channel by hitting the super thanks button. But if you can't do that, you can always like, comment, subscribe to the channel. All right, my good people, we are done with this question 4.2. Let's go and do 4.3. Right, my good people, let's look at 4.3. Now here is our 4.3 here, guys. Wanna copy it again, paste it where there is space, and then we solve it. All right, here's our 4.3, guys. So what we need to do here, guys, is to differentiate using one of the rules. So let's read the question. So the question goes like this: given you have y is equaling to 5 sec 2x, and then what they want us to do here, they say we must differentiate with an aid of a function of a function or chain rule. So basically here they want us to differentiate this expression here using the chain rule or function of a function. Now I'm gonna rewrite this expression. Again, we have y is equaling to 5 sec, right, to x. There we go. So they want us to differentiate this here using the chain rule. Now when you use the chain rule, guys, you need to be able to find the inner function and the outer function. Now let me just highlight with colors there. So I'm gonna highlight the inner function with red. So 2x here, guys, it's the inner function. And then I'm gonna highlight the outer function with green, right? And then the whole thing there, it's actually the outer function. All right, so you must able to substitute the two. So like I said, the red color will represent the inner function. So the inner function, I'm gonna equate it to u, guys. So if I equate the inner function, which is 2x, and then the outer function, I'm gonna equate it to y, right? So remember, we have the coefficient there, which is 5, right? And then we write sec them, but instead of writing 2x, we're gonna write u. Remember, 2x is equaling to u. There we go. Then from there, my good people, we derive each term. So I'm gonna derive this one first, where we can say du over dx. Remember, we are deriving u with respect to x. So this is the standard derivative. So this is gonna give us 2. There we go. And then we derive the second equation, which is dy over du. We are deriving y with respect to u. So this is going to give us 5, right? And then the derivative of sec, my good people, it's sec u multiplied by tan u. Do not forget that, guys. This is there on the formula sheet. So make sure that you double check. The derivative of sec is there on the formula sheet. Now the next step, guys, is to find dy over dx. So there is a formula for chain rule. I'm gonna do it here. So when you find dy over dx, guys, you have to multiply du over dx with dy over du. There we go. So basically you have to multiply these two equations and then you get your final answer. So let's continue. Du over dx, it's 2, is this one here, guys, right? Multiply by dy over du, which is this one there. So multiply by 5 sec u multiplied by tan u. There we go. So if you say 5 multiplied by 2, this is gonna give us 10. So multiply by sec. Instead of writing u, remember u is equaling to 2x. So this is gonna give us 2x multiplied by tan 2x. Guys, this was free marks there, guys. Right? These were free marks. Again, people, if it so happen that this chain rule you don't understand it, I made a video. I will leave that video in the description that explains the chain rule and the application of the chain rule. So go to that description and click the link, and also the video will pop up on the top right of the one that you're watching at the current moment. But if you understand, you can always like, share, comment, and subscribe to the channel if you haven't subscribed. If again somewhere on this video you got lost, you can go to that point, rewatch it, and if that doesn't help, you can leave a comment in the comment section, guys. You can always support our channel by hitting the super thanks button, but if you can't do that, a like, a subscribe, a comment will be highly appreciated. I hope you managed to get this question. Really, it was not that difficult. We are done with 4.3. Let's go and do 4.4. Let's look at question 4.4. Now I'm gonna highlight it here so that you can see it. So here's our question 4.4, guys. Again, this one I am going to copy it, paste it where there is a space, and then we do it. Right, guys, let's look at 4.4. Now 4.4, they want us to differentiate this polynomial, but this polynomial, it has 1 2 3 4 5 6 7 terms. So before we differentiate this polynomial, there is some lot of simplification required. So let's start by simplifying before we differentiate. Now let's look at the first term. Our first term, we have pi over 3 divided by x to the power of negative 3. So we can rewrite this one here as pi x to the power of 3 divided by 3, right? Because we cannot differentiate with x on the denominator. So if you take it to the numerator, it will become positive, right? The exponent. Now we go to the second one. We simplify it as well. We have e to the power of negative 4x. So we also need to take this e to the numerator. So we're going to write 3p, and then we have e to the power of 4x. Remember, the sign changes when the base go to the numerator or the denominator, depending where we are taking our base there. And then we have this third term. We have 1 over cosec 4x. Guys, we cannot differentiate with the trigonometric ratio on the denominator, so we need to use the inverses there. We all know that 1 over cosec x is equaling to sine. These are reciprocals, guys. Just in case you don't know much about reciprocals, I'm going to leave the video on the description, and the very same video will pop up on the top right of this video that you're watching here. So we can change this into sine 4x. There we go. And then we have the following there, which is negative ln over pi over 8. So this is supposed to be over 8. Guys, you can write this as minus, right? 8 ln x over pi. There we go. And then we have 10 to the power of 6x minus cos 3 pi plus 9t x. Alright guys, we are done simplifying each and every term here. So it's time for us to differentiate. So dy over dx is going to be equaling to, let's look at our first term. Our first term is the standard derivative. Remember, we multiply by the exponent, which is 3 there, and then we multiply the coefficient, which is our pi, and then we have 3 minus 1, and then we divide by the 3 there. There we go. And then minus the second term, it's exponential because our x is exponent. So we're going to multiply the 4, the coefficient of x, with our coefficient of the base, which is 3p. And then we also multiply e to the power of 4x, and then we introduce ln, and then our base there is e. There we go. And then we look at our third term, which is positive sine 4x. Now this is a trigonometric ratio, so we're going to multiply by the coefficient of x, in this case, which is 4, and then the derivative of sine, we know that is going to be cos, but let us not forget to write 4x there, and then minus. Now we look at this fourth term. The fourth term here, we have 8 over pi. That is our coefficient, guys. And then we derive ln x, or natural log x. The derivative of ln is 1 over x. There we go. And then we continue there, plus, and then this term here, as you can see, our x is an exponent, so it means this is an exponential derivative. So we multiply by the coefficient of x, which is 6 there, multiply by 10 to the power of 6x, and then we introduce ln, and then our base there is 10. Guys, never multiply this 6 with that 10, because the 10 is actually the base, while the 6 is a coefficient of x. So that is a common mistake people do. And then we look at the second last term, which is this one here, negative cos 3 pi. There is no x on this term, guys. It means this is going to be negative 0, because we are deriving with respect to x. Right, the last one here, we have 9tx. So we can see the answer here, it's 19. There we go. So this is how you're supposed to derive this. So you can simplify it further, guys, by dividing this 3 with that 3, as you can see. Now what are we gonna have here? We're gonna have pi, and then we have 3 minus 1. This is gonna give us squared there. And then we continue on the second term. We have 4 multiplied by 3. This is gonna give us 12 multiplied by p, and that is gonna give us 12p. And then we have e to the power of 4x. But look, we have ln e, guys. Ln e is equaling to 1. Even if you don't write it, it's fine. And then we continue. We write the third term, which is fine like that. We don't do anything. 4 cos 4x, right? And then we do the fourth term where we can multiply 8 with 1. That is going to be 1 on the numerator. And then we multiply pi with x on the denominator. We're going to have pi x. Right. And then we do this one here. We're going to have 6 multiplied by 10 to the power of 6x ln 10. Guys, don't multiply 6 with 10 to the power of 6x, guys. It's not allowed, right? And then we write -0. Guys, include the -0. Very, very important. Sometimes it's a mark, sometimes it's not. So don't risk it. Just include it. And then the last one there's no simplification required. It's just 19. Guys, this is our final answer after simplifying. Remember, guys, here we had fractions, so you're supposed to simplify them, and you're also supposed to simplify this, you're supposed to simplify that, you're supposed to simplify this as well. So if you didn't know how to simplify these terms that I highlighted them, you are going to have some serious challenges. Guys, if you didn't understand what I did here on each and every term, I've made videos on differentiating the polynomials. I'm going to leave the playlist that contains those videos. You can go and watch those videos on that playlist on the description, and also that playlist is going to pop up on the top right of this video here. But if you manage to understand, do not forget to like, share, comment, and subscribe to the channel. All right, you can always support our channel by hitting the super thanks button. If you can't do that, a like, a comment, subscription will be highly appreciated. Guys, we are done with question 4 as a whole and question 4.4. So when you subscribe, guys, do not forget to hit the bell notification, so whenever I upload the video, you'll be notified. Thank you very much, guys, for watching. Cheers.